Hi there. Hey, this is Dr. Tech recording the last video before the final exam. And this one is about the homework assignment, the last homework assignment. I didn't quite finish the whole thing, so I'm gonna finish the entire program. As you can see here, we got traverse, and traverse is partially implemented because we were talking about just testing a portion of it. So here's traverse, and we are done with just this portion here. And I think I lost the other one that actually loaded the value of the structure pointed to by PTR. So we're gonna fix that. So we'll do this whole thing again here. All right. So at this point we have not copied anything. We have not pushed anything on the stack. As a result, the stack pointer would still be pointing at the return address, which means we can now access the parameters through the stack pointer again. So instead of putting a 56 into register B, we want to put the actual um, member value of whatever of the structure that is pointed to by PTR, and push that on the stack. I mean, not push on the stack, but put it into register B, because that's at the right hand side of the assignment statement. So we're going to do that part here. Alright, so we need to get to PTR first. So we'll load, we cannot mess with register A, but we can use register B or C. Preferably not with C, because C is already auto incrementing here. So we want to just use register B, which may be a little bit difficult. And in class, I think I pushed the register on the stack. So there are a few ways to do it. I'm gonna erase this code here. So we basically just have to recompute the address of array and what it points to. But that's okay. That's we can then remove this line as well, because we are not saving it for later. All right. So now we have register B and C to use, which is handy because we got two registers, and that's what we need. The first thing is to load A with PTR, which is the offset of the parameter from where the stack pointer points to, and then we add AD, which makes register A now the can't use register A. Let's use register B here. So now that makes register B the address of the parameter PTR. And then if we do run the reference using load, then we have B being the actual parameter of PTR, which is close to what we want, because it is this B now has the address of the structure that we want to access. So the next thing that we need to do is to add to this address the offset to the member value in that structure. So we can now use another register, which is register C, and we'll okay, I have to there you go. Okay, my cat was interfering a little bit there, and now we can continue. Okay, so node value is loading into C, and then we have to add these two, because node underscore value is the number of bytes that the value member is away from the beginning of a struct node, and B already has the address of a struct node. So when we add these two, we get to the address of the member value of the structure that PTR is pointing to. So now B is the address of the value member of the structure that PTR points to. Now, of course, we are not interested in the address in this case, because we actually want to retrieve the value. So we want to do one dereference, so that now P is actually the value member of the structure that is pointed to by PTR. And then the assignment operation is just a simple ST, because at this point register A is what parameter array is pointing to, which by itself is also a pointer, and register B is the value that we want to store, and then we go back to auto increment what array points to. So since we are not messing around with the stack pointer, we can just use pretty much the same concept. Add AD. So it's really handy to write that at this point, A is the address of parameter array, and then we have 1 dereference. So the A is now actually array, which is close to what we want to do, because we want to auto increment whatever array is pointing to. So we are close to what we want. This is the address of what we want to increment. So we now say LDB to A. So B is now actually whatever array is pointing to. And then we increment B. So that B is now whatever array points to plus 1. And then once we have this calculated, we have to store that back to whatever register A is pointing to. So now we have to say whatever array is pointing to is whatever array is pointing to plus 1, and therefore we are done with the post increment. So this code here should implement the code to put the value of the value member of the structure that is pointed to by PTR into whatever into the location pointed to by the pointer that is pointed to by array as a parameter. Okay, so let's go ahead and check this out and see whether this works. Okay, Control C, Control A, Control C, and then go back to the assembler and replace the entire column A. Get rid of that, and then Control V to paste this code. And if everything checks out, RAM files should be good. Yep. So we are good there, and then we download as CSV, and I'm going to give it a name of you can't see this part, but it's okay, it doesn't really matter what name I save it as, so I'm just going to save it as node.csv into my temp folder, and then we will go ahead and run it in this particular window. Alright, so this program is called node, and we're gonna output node as its TSV in the temp folder. Pressing the key, so everything seems to work fine. So now we go back to the trace analyzer and see if we can import that data. I might need to break up this recording into 2 halves because I got an errand to run right now. So let's go ahead and just do the import and go to upload, and then we look up node.tsv, and then replace current sheet, use tab separator, click no here, import, and then go to sheet 2, and the most important part to analyze would be RAM write. So we are just looking here to make sure that the location in RAM is in fact updated. Okay. Okay, I'm gonna continue this recording later.